Inside this Astranis satellite is literally tens of thousands of wires. If you took those wires and stretched them end to end, you could go across the entire Golden Gate Bridge, which is crazy because our satellites are roughly the size of a washing machine. These wires have to survive in space, which means crazy 100°C temperature swings, the radiation that comes from the sun and deep space, and the crazy shaking vibration environment of a SpaceX Falcon 9 rocket launch. But despite all this, not a single wire can fail because electrical failures kill satellites. And once you're in space, there are no second chances. Luckily, we have the right team for the job. Our in-house harnessing team is a world-class group of wire harnessing experts. You'll get to meet them today, and they'll explain to you what wire harnessing is, how it works, and why it's so important for our satellites.
Satellites are made up of a series of tiny electrical systems that all combine to make one large computer that lives up in space. These systems include things like power, avionics, payload, and TTC. And while we can make and design the best systems in isolation, none of them would work without wire harnessing. Wire harnesses are literally wires, terminals, and connectors that run through the entire satellite and literally connect everything. It transmits vital information across the satellite from one system to another, all while surviving in the deep space of GEO. Wire harnessing is responsible for two key elements. First is power distribution. Without power, nothing would work, and the challenge is delivering the right amount of power to every component. We have a huge range of conductors, varying from a tiny 28 gauge to a huge 8 gauge wire that carries from 1.5 watts to 2.5 kilowatts. Think of this as your Apple Watch compared to an industrial machine or even industrial motors. To accommodate this, we use a strong copper alloy tinned with silver, the most optimal combination of mechanical strength and electrical conductivity.
The second element of harnessing is to transfer signals. Every single subsystem on the spacecraft needs to be able to communicate with one another, and to do that, we have different communication protocols. Ethernet you might be really familiar with. That's sort of like your internet, but it can also provide communication between different things. RS-422 is something that maybe more of the older generation knows about, and that's a simpler communication protocol, but another way to communicate between different systems. So we have a component on the spacecraft called sun sensors, and they provide data for where the sun is, and it communicates that data in millivolt level ranges. So if you're off by a couple millivolts, which is a very small amount of electricity, then it could think that your spacecraft is somewhere completely different than where it actually is. To connect all these wires, we have something called terminals. The terminals are the actual metallic component that goes inside of each connector, and they're sort of the bridge between the wire and the board that it's connecting to. We'll use a lot of gold-plated terminations. Gold is a very good material because it's very conductive, and it's also relatively inert compared to other metals.
Terminals then lead to the final part of wire harnessing, connectors. So connectors are all about reliability, and their whole purpose is to keep these terminals fully mated to another terminal on the opposite end so that all of our power and signals go uninterrupted. We cannot lose connection, have intermediate connections, or have any voltage drops. If we do, then our systems will not work. So these connectors are absolutely crucial to make sure that these terminals connect and stay connected, because these satellites have to survive up in GEO for at least 10 years.
Our micro-GEO satellites are in one of the toughest orbits in space, geostationary orbit. In GEO, our satellites constantly experience extreme temperature ranges. They can reach up to 150 degrees Celsius in direct sunlight to negative 150 Celsius when the sun is eclipsed by the Earth. Normally, the atmosphere and Earth's magnetic field protect those of us on Earth from the extreme radiation environment of space. But in GEO orbit, we don't have that luxury. Once you're in GEO, you're outside of Earth's atmosphere and magnetic field, which means you're constantly being blasted by radiation from the sun and from galactic cosmic rays. This effect is also multiplied by all of the particles trapped in the Van Allen radiation belt. If any of these high-energy particles are absorbed by our wires, it can cause big voltage or current spikes, can cause bit flips in our electronics, and can generally cause huge problems with the spacecraft. And we're in this environment 24/7. For these reasons, it's important to add some extra protection to our harnessing and our electronics. Shielding. So on many harnesses, especially those exposed directly to space, we add a lightweight metal braid to help shield those bundles from electromagnetic radiation. This way, if a high-energy particle comes into contact with our harness, it gets absorbed and transferred down to the spacecraft body instead of into the wires and into the electronics. Thanks to the shielding and the rest of these design processes, the wire harnesses in our satellite are resilient to GEO orbit and can survive in space for more than 10 years. This allows our micro-GEO satellites to fulfill Astranis' mission of connecting millions of people back on Earth who need affordable internet.